The third and final topic that we're going to cover in this area of exponents is negative exponents. And our goal is to write and evaluate expressions with negative exponents. So let's look at the table that we have here. We want to complete this table. So on the left side, you can see what we're doing is we're reducing each exponent by 1. So that would be 2 to the 0. That would be 2 to the negative first, 2 to the negative second, and 2 to the negative third. So on the right side, hopefully you can see that we're dividing each number by 2. Well, you've already learned that anything to the 0 power is 1. But now, when you look here, you'll see we're getting fractional answers. So what's the pattern that's happening? As the exponents are being decreased by 1, the value is being divided by 2, which is the base. What we say in the rule is that if we have a base raised to a negative exponent, we rewrite it as 1 over that base, but with a positive exponent. Now, let me explain and show you how that works with a numerical example. Let's say I have 5 squared over 5 to the 5th power. You learned yesterday that 5 squared over 5 to the 5th, or actually 2 days ago, that with the laws of exponents, that would be 5 to the 2 minus 5, which is 5 to the negative third. Right? You've also learned that 5 squared is 5 times 5 over 5 times 5, that number of times. We would cross cancel or cancel out the common 5s. And what are we left with? 1 over 5 to the third. Well, we started at the same place. So what you're telling me is 1 over 5 to the third is equal to 5 to the negative third power. So our explanation is any base with a negative, and I'm just going to erase this so I have some room. Any base with a negative exponent can be rewritten with a positive exponent by moving the base from the numerator to the denominator, or vice versa. Okay. Now, just so that you understand, what does an exponent tell us to do? Why must it be a positive number? Well, an exponent, just to show you this numerically first, and then we'll do, I'll give you the word explanation. If I have 2 to the third power, that exponent of 3 tells me to multiply 2 by itself 3 times. If you think about it logically, if I had 2 to the negative third power, how can I multiply 2 by itself negative 3 times? That doesn't make any logical sense. So that is why we need to rewrite this in a form that gives me a positive exponent, so that now I know it's telling me multiply 2 by itself 3 times, but that is now the denominator in my number. So just to finish this up here, an exponent, it tells us how many times to multiply the base by itself. How can you multiply a number by itself a negative number of times? The answer is you can't, which is why this has to be converted. The other thing I will tell you, the other very common mistake students make is negative exponents do not mean negative numbers. Okay? In actuality, negative exponents result in numbers getting smaller. All right, so let's go through some very quick examples. 4 to the negative third is 1 over 4 to the third power, which is 1 over 64. In example 2, only the x is raised to the negative power, so only the x needs to move. Okay? And in 3, only the b is raised to the negative power, or negative power, so only the b needs to move. Write 1 over 36 using a negative exponent other than 1. And just so that you can see, okay, write 1 over 5 squared using a negative exponent. That's 5 to the negative second. Okay. Now, key point. We learned over the last couple of days operations involving exponents. And the operations were multiplying, dividing, power to a power with positive exponents. The rules are the same when the exponents are negative. All we just need to do is to make sure at the end of the day, we end up with a positive exponent as our final answer. So in number 1, we learned that we add the exponents, so it's just x to the 5th. In number 2, and I'll show you 2 different ways you can do this. The first way is you can say negative 4 minus 1, okay, because you're subtracting the exponents. So you would get 6x to the negative 5th, which is 6 over x to the 5th. That's one way to do it. The other way to do it is I have 6x to the negative 4th. To make the x to the negative 4th a positive, I would move it to the denominator and then clean it up that way. Either method works. Whichever method you are more comfortable with, go with. You don't need to do both. And this is 1 over 2 to the 4th. You don't necessarily always need to take the additional step of writing 2 to the negative 4th and then 1 over 2 to the 4th. Okay? Continue on with our examples. Okay? We would distribute the negative 5, and then we need to move x to the negative 20. Okay? Now, in this example, there's a couple of different ways this can be done. Number 1, I can distribute the negative 3 to all of the bases, and there's 4 of them, 3, 8 to the 4th, 12, and 8 to the negative 2nd. So let's do that one first. Then I can move whoever has a negative exponent. So 3 to the negative 3rd has to go down here. 8 to the negative 12th goes there. 12 to the negative 3rd goes up there. 8 to the 6th stays where it is. I'm going to evaluate this. And simplify. Okay? That's one way to do it. All right? Now, a second way that you can do this is this entire fraction is being raised to the negative 3 power. If I were to take the reciprocal of that fraction, I don't change what's there, I just take its reciprocal. I then would be converting the outside exponent to a positive, and then I can distribute. And then I would be just about where I'm here. And I would get my final answer. Again, both methods will always work. It's a question of what you are more comfortable with. Okay. I'm just going to write the next one underneath here. This is a to the third. You could either do -1 minus a -4, which gives you a +3, or you can invert them so that you got a to the fourth over a to the 1. Doesn't matter to me. Answer here is 6 over a to the fourth. And the last two, and my orientation is a little screwy already. This would be 3 times 1 over 2 to the fourth, which is 3 over 16. And then the next one, this is 3 times 1 over 100, which is 3 over 100, which in decimal form is 0.03. So the two key points with negative exponents. Number one, negative exponents do not mean negative numbers. They really mean that the numbers are going to get smaller. The numerical values will get smaller. And number two, you want to always rewrite the base that has a negative exponent as a base with a positive exponent, and then evaluate.